Alright, time to prepare for your test on trapezoidal rule and U substitution. We're going to start with the trapezoidal rule problems here. What you need to do is you need to create a table with x and f of x. Your x value needs to start at 1. If I want 6 intervals going from 1 to 4, that means to find how big each interval is, I take this difference, 4 minus 1 is 3, over the number of intervals 6, so I need to count by 1/2. So 1, 1.5, 2, 2.5, 3, 3.5, and 4 as my x values. Then, to do my y values, I'm just going to plug in f of x. So 1 squared is 1, times 2 is 2. Then this becomes 4.5, this becomes 8, this becomes 12.5, 18, 24.5, and 32 for my f of x values. From there, all I'm going to look at, well, 3 over 6, that equals 1/2. This is my height for everything. So that's my height. My height equals 1/2. What I'm going to look at, my formula is 1/2 base 1 plus base 2 times my height, which is 1/2. So I'm going to look at each one of these separately. So I'll have 1/2 times, my first two bases would be 2 plus 4.5 times the height of 1/2. I'll do the same thing the whole way down. 1/2 is my height, or is my number in front for all of them. 1/2, 1/2, 1/2. I should have, then at the end I should have 1/2 at the end for each one as well. So there's a 1/2 there, 1/2 there, 1/2 here, 1/2, and 1/2. My numbers in the middle are the only thing that changes. It should be 2 and 4.5 for the first one, 4.5 plus 8 for the second one, 8 plus 12.5, 12.5 plus 18, 18 plus 24.5, the last one, 24.5 plus 32. When I add all these up, I should get an estimated area of 42.25 for my answer. Alright, now let's look at the second one here. Same thing, I want to make a table of x and f of x. So there's x, there's f of x. I got to start at 0. My range goes 1, and I have 3, so 1/3 should be what each interval is. So 1/3, 2/3, and 1. When I do x cubed, 0 cubed is 1. This becomes 1 over 27. 2/3 cubed is 8 over 27, and 1 cubed is 1. Okay? So I'm still going to have 1/2 times two things. My height this time now is 1/3 though. 1/2 times two numbers, 1/3. 1/2 times the sum of two numbers times 1/3. This should be 0 plus 1/27. This should be 1/27 plus 8 over 27. And this should be 8 over 27 plus 1. Okay, and when you add all these up, you should end up getting a total area of 5 over 18, which is the same as you put in decimal point 278. So depending on if you round it here, I would say keep it as fractions if you can, but 5 over 18 or 0.278, close to that is what you want to get. Alright, numbers 3 through 8 here are all doing derivatives, so let's see what we can get with these. When we do a derivative of e to the x, remember, the derivative of e to the x is just e to the x. So when I have something other than x up here, first I'm just going to rewrite that part, e to the 4x, times the derivative of the inside, times the derivative of 4x, which is just 4. So 4e to the 4x. Same thing here, except we have product rule. So first times the derivative of the second. Derivative of that is just e to the x plus 4. Plus second times the derivative of the first. Derivative of x is just 1. So that's your final answer. That's what f prime of x is. For this one here, same thing. E to what's up top plus 4x minus 2. Now you need to multiply that by derivative of what's in the x term, which is 2x plus 4. Make sure that's in parentheses there. Number 6, now the other one, for natural log. The derivative of natural log of x is just 1 over x. So the way we do these, whatever's on the inside, I put in the denominator. And then I have to multiply by the derivative of the inside. So times 2x. So simplifying that, that's 2x over x squared. That simplifies into just 2 over x with the x and x squared helping to cancel each other out. Number 7, we can do either quotient rule or product rule here, whatever you care. I'm going to do quotient rule, so I'm going to say low times d high minus high times b low all over low squared. And then I'll simplify it. This x times 1 over x, this becomes 1. This part will become ln of x, and my denominator is x squared. So quotient rule is probably the safest way to go for that one. And then the last one, 2 times the ln of 5x, same thing. The 2 is going to stay out front. I want to do 1 over 5x for the ln, times given the inside though is 5. So that's just going to become, the 5s will cancel each other out, and I will have 2 over x again as my derivative. Now, the fun ones, the integrals, the antiderivatives here. Okay? So number 9, you have a couple different options, actually. What I'm going to say to do is you're going to set u to equal sine of x. That means du will equal cosine of x times dx. So that means when I rewrite my integral now, I'll have the integral of sine of x is now u, cosine of x, and dx is du over cosine of x. So du over cosine of x. So that means, pretty easy to see that the cosines cancel each other out, and I end up with the integral of u du. The integral of u, that's u to the first power, so it's going to be 1/2 u squared plus c, which is the same as 1/2 of sine squared of x plus c when I plug back in for x. Okay, number 10. Same thing, which is the derivative of the other? 2x cubed minus 4. When I take a derivative, I'll get something x squared, which is what I want. So 2x cubed minus 4, my derivative of that is 6x dx. So now I can simplify. It's the integral of x squared up top. My bottom is now u. dx, when I simplify it down here, is going to be du over 6x. Should have been 6x squared, my apologies. So now I can look and see, well, my x squareds will go away. My 1/6 here, it's a 6 on the bottom, that'll come out to the front. And I have 1 over u du. Remember, 1 over u is when I have the integral, and this is to the first power. That means I'm going to have the natural log. So when I take the integral, so that's 1/6 times the natural log of absolute value of u plus c. Means when I simplify, 1/6 natural log, plug back in u here, should be 2x cubed minus 4 plus c. And number 11, we want to look at here, I only have 2 options for u. It can either be ln of x or it can be x. Well, if I take u to be x, my derivative is 1, nothing will cancel out. So that means I should want my ln of x to be my u. The derivative of ln of x is 1 over x dx. That means right away I can say, well, dx would be, how do I get this by itself? I multiply both sides by x. That means that dx is equal to x times du. So, again, to rewrite my integral, it's now the integral of ln of x is now u, x on the bottom, and dx here we said is x times du. So, again, we notice just like we want, things canceling each other out. So I have now the integral of u du, same as we have in number 9 up here, so I'm going to have 1/2 of u squared plus c, and then plug back in because I don't want u, so I'll have 1/2 of ln of x squared plus c. Coming down the home stretch, number 12 here. For number 12, what we're going to say here, same thing, which is the derivative of the other. I'm going to say u as x squared because du, its derivative, is 2x in terms of x dx. So, this is still the integral of, I'm going to keep the x, I'm not going to make it e to the u power. dx here is now going to be du over 2x. As we would expect, and as we would hope, we get things to cancel out. I have my x's that I need to go away, and I'm left with the integral. I have 1/2 out front from this 2 on the bottom of e to the u du. And same thing as before. The integral of e to the u is just e to the u. So I can essentially get rid of my integral here. 1/2 e to the u plus c. I don't want u. I need it to be back to x squared. So 1/2 e to the x squared plus c. Alright, next one, 13. Pretty much it's going to be pretty simple what we're going to have to make u as. It's going to be our inside function, 7x minus 9. du here, well, derivative of that, pretty simple. Just 7 times dx. So this is going to be a very basic one. I'm now going to have the square root of u. dx is now du over 7. I'll rewrite this as 1/7 for that number. I'll make it u to the 1/2 because that's what we like better. We don't like square roots of du. When I evaluate that integral, I keep the 1/7 out front. My new exponent is 3/2, which means my coefficient out front is 2/3 plus c. From there, just simplifying, this now is 2 over 21. I don't want u anymore, so I'll make it 7x minus 9, 2 3/2, and plus c at the end again. Alright, down to the definite integrals, and these are the ones that you can do two different ways, so let's see how we do. First, for number 14, I'm going to say that u is equal to, again, I have x squared minus 6 and 4x. 4x is the derivative of this bottom function, so the bottom function is what I'll make as my u. That means du is equal to 2x dx. When I simplify that, because I've changed my variable, that means that I can't look at my limits yet. I need to forget about my limits for a minute. So I'm going to keep 4x up top, and my bottom is now going to be u cubed, and dx is now going to be du over 2x. So when I simplify that, I have things canceling each other out. The x's go away. 4 divided by 2 just becomes a 2 out in front, and my integral now is, it's a very crummy integral, but my integral is 1 over u cubed du. That integral can be evaluated not using ln, because this is not u to the first, it's u to the third. So this is the same as saying u to the negative third power. So that means I'm going to keep my 2 there. I'm going to have u to the negative 2 power. What do I have to have as my coefficient? Oh, it's dividing by negative 2. So that's dividing by negative 2 plus c. Actually, no, not plus c, because I'm not doing an indefinite, I'm doing a definite integral this time. So I'm going to be evaluating it for something. So first, let me rewrite it. I don't know what I'm going to evaluate it at yet. I still want to try to simplify this. 2 divided by negative 2 is just negative 1. So it's negative u to the negative 2 power evaluated at something. I don't know yet. To find out what it is, let's put it back in terms of x. So negative x squared minus 6 squared, that I can evaluate. I can evaluate that from our original numbers of x is 0 and x is equal to 4. When I do that, I should get plugged in a 4 here. 16 minus 6 gives me a 1 over 10 squared, 1 over 100, and then subtracting, well really adding, because I got to subtract a negative, that'll become negative 6, so 1 over 36, which gives me an answer when I do this. When I simplify it out, I should get negative 2 over 9. Now, if I had done the other way, which would be changing my limits, the way I would change my limits here is when x equals 0, that means that u must equal some number. When x is 0, well, u is going to be negative 6. So that means I can make this limit negative 6. Same thing here. When x equals 4, my top limit, that means I'm going to have 16 minus 6. So u will equal 10. So from negative 6 to 10, which means that's what all these would be the whole way. Negative 6 to 10, negative 6 to 10, negative 6 to 10. And I could go and evaluate these immediately too. So if I went that way, I would have negative 1 over 10 squared, so 1 over 100, minus a negative 1 over 6 squared, which is 36. Well, guess what? That's the same exact numbers that I got right here, so that's going to equal negative 2 over 9. It would help if we had a problem that was capable of being solved, meaning that I was written down the right problem. This should be not from 0 to 4, but 0 to 2 everywhere. That should mean right here that this should still be from 0, not to 4, but 0 to 2. So my top here should be 2 squared is 4, minus 6 is 2. So this should have been negative 1 over 4. That's how I get my negative 2/9. Same thing here. When my top limit is not 4, but 2, that should mean that my top limit here is 2 squared minus 6, which is negative 2. So this should be negative 2, negative 2, negative 2, negative 2, which makes this, again, negative 1 over 4 plus 3, 6. That's how we get our negative 2/9 as an answer. The reason we can't do from 0 to 4 is because, well, we have a discontinuity in between. something bad happens there between 2 and 3, so we can't do that. So my apologies on that. We'll make sure we discuss that in full for our next class. All right, last one here, so we can call it a day. U is going to equal, U is going to equal this, negative x squared plus 4. That means that du will equal negative 2x times dx. So, changing this, it's now x times u cubed. Dx is du over negative 2x. So, negative 1/2. Again, I don't know what my integral limits are yet. These are question marks. Negative 1/2, the integral of u cubed du, which is the same as, when I evaluate that integral, it's now going to be 1 over 8 times u to the 4th. I'm not doing plus c again because it's a definite integral, so 1/8 of u to the 4th. So 1/8, I don't want u, I want it to be negative x squared plus 4. That I can evaluate. I evaluated at 1 and I evaluated first at 2. So 1/8, this should be to the 4th power here. When I do this, plug in 2. 2 squared is 4, negative that is negative 4, plus that is 0. And then minus 1/8, should be negative 1/8, so minus a negative again. But negative 1/8 of, when I plug in 1 there, I should get negative 1, so I should get 3 to the 4th power for that. So that's plus a positive, so I should get a positive answer as a result. 3 to the 4th power is 81, and over 8 is my answer, 81 over 8. And same thing, if I change my limits here, when x is 1, by plugging 1 here, I should get that u is going to equal negative 1 plus 3, or plus 4, which is 3, I mean. And for the top limit, when x is 2, that means that u would be 0, because 2 squared is 4, negative 4. So my bottom limit, when x is 1, it's now u is 3, and this is 0. So I can go 3 and 0 that way, and plug in right here 3 and 0, which would mean negative 1/8 times 0 minus negative 1/8 times 3, all those to the 4th power. That should be 1/8 times 81, which is 81 over 8. Well, hopefully that was somewhat constructive and able to be followed. It looks like a lot of chicken scratch right now. So we're going to continue with this, and hopefully you should be ready to go. Just make sure you know whether you're changing your variables or not when you change your limits, and you should have no problem beyond that.